Hello everyone. We are the electronics development company. Yes, our main specialization is power electronics and energy storage and automotive propulsion systems. Basically, what we do, our primary business is we design large devices for energy converters, energy storage systems, and automotive propulsion systems and drives. Now, the scooters is our side project. So what we have done, we have made a platform in which we take in the best technology which is used in automotive industry and translated it into the scooter. So we have increased the capabilities of the system, and the price and cost of all the electronics which we have implemented stays same low as in every stock devices which you can buy on the market. Now, our platform, because we call it platform, consists out of the engine. This is the stock engine which has been slightly altered. It consists out of the battery, the controller, the lock if it is necessary, but lock is not our device, and the display controller, which also supports everything which on the handlebar, including the charging system. Now I will be more specific in describing every part differently. Our main technology is this, that we can take a standard stock motor. This one in particular is 115 millimeters, the stated diameter, and the magnet's width is 40 millimeters. So this is the standard stock hub motor which is used in many scooters. What we have done, we have changed the electronics inside the motor, basically the PCB, which with the Hall sensors, we have replaced it with our PCB with microcontroller, and have added additional data cable which comes into our controller. Now, what does it give? This technology allows us to drive this motor with the field-oriented control, but not just simple field-oriented control, which is Hall-based technology, which is on the market, but with extremely high precision that it allows us to gain approximately 15 to 30% of efficiency and the torque. How it happens? A special controller inside the motor, which is just a small replacement PCB board. It monitors the electrical angle of the rotation of the rotor, and over a special interface translate this data into main controller, which can supply up to 150 amps of phase current. Also, it monitors the temperature inside the motor. Also, it has many lock features. It assesses the capability of the motor, the control which is inside the motor, and many other data. So basically, this technology is very similar to automotive technology. It actually works in approximately the same manner, but we can detect the electrical angle of this motor much more precisely even than in automotive industry, even with the most highest resolution resolvers, for example. So in this case, to show how this technology works, I'll demonstrate it over the thrust. Now, how it works. With this technology, we are able to obtain the highest torque of the motor starting from the 0 RPM, and we are able to precisely control it from 0 Newton meters to 42 Newton meters. Standard hub motor from the stock can supply approximately 20 to 25 Newton meters depending on the controller which is used. We're able to take from the same motor, nothing changes except electronics, approximately double the size of that, because of much more advanced electronics and much more advanced mathematics which we used. By the way, all the electronics is China-made microcontrollers, and most of the parts are China-made, so it's really cheap and really competitive compared to anything which is on the market. Now, how this technology works. When I add a little bit of thrust, you see the motor starts to spin because it is a field-oriented control. But I can hold it, and you can see that motor supplies the torque all the time. I can even spin it back, but it goes forward because the angle is measured real time, all the time. So, see, so when I push it back, actually there's a force, and then harder than I press on the thrust, then more torque it gives. At some moment, I press the accelerator so hard that I cannot hold it anymore. So, what does it give? First of all, it gives you, depending how hard you push an accelerator, it gives you a very, very smooth and very, very precise and firm acceleration, much more higher than of any scooter on the market. Now, also, it doesn't jerk. So basically, when you push it, it accelerates really smoothly. It doesn't look like this. It's just smooth. Also, as you've seen on the previous videos, you can, especially in the city, in the crowd, you can drive really, really slow with all sorts of obstacles, people and pavements. But because the torque is so high, you do not fall from the scooter. You feel really, really confident on it, and you can overcome any obstacle, even like pavements like that high, without a hard acceleration, without like bumping into it, without any strong force. Because all the other motors and controllers on the market, they need to have like speed approximately 10 to 15 kilometers an hour before they can maintain their torque on the motor. This motor maintains the torque starting from the zero kilometers. So that gives like really, really high confidence. On top of that, it gives better efficiency, and also it runs much, much cooler. So basically, without losing any speed, you can drive uphill, like really, really steep uphill. The video which you've seen in the chat is the video where we did the ski mountain without any roads, and saying this scooter drives uphill like without even without any speed decrease. So basically, it drives uphill exactly at the same speed as on the plains. So you don't feel any difference. And because the frequency at which we control the motor, it's like extremely, extremely high, because our controller is really advanced. We use 50 kilohertz PWM modulation that also benefits in really, really quiet run. So when the motor runs, it's like really, really quiet. You can hear. And we are in a room. You can hear that it's like really, really quiet. It's much more quieter than any on the motors. And it's not because of the motor, it's because of the way it is controlled. Let me show it one more time. Wait a second, I'm trying to push the accelerator. Okay, there it is. So it's like really, really quiet. Now, the second part is the controller. Let me show it. The controller could be placed anywhere in the deck, but because it's got a heat plate, preferably if it's placed somewhere like that, or maybe at the bottom, it doesn't really matter. This is the prototype, and this case has been printed. Nevertheless, by the way, this lock is also CAN protocol controlled. It's also part of the network. Now, into this controller, it comes one wire, it's data wire, this one, from the motor, and the power wire, which is this, also comes from the motor. Now, all system is interconnected into the CAN network. So, and the display connected with the battery and the controller via a single 7-thread wire cable, 7-wire cable to be precise. Now, the battery, well, this is the scooter front. Therefore, this battery is a removable battery. So, controller connects to the battery via this standard cable. Well, in the just for the scooter, for the normal market, not for the rent, this battery could be slightly smaller, and connection cable could be much simpler and much thinner. But because of the regulations and customer demands, it has to be like this big and like this really, really robust. So, controller, motor, lock, battery, and the display, they're all connected in one single CAN network. How it works? Every device has got its own serial number, which runs along the network. And there is a special code which is generated by our server. And before all these devices can work together, they must pair. Pair is like to identify each device, receive a special code which says that these devices, all of these devices with these serial numbers, can work together. If there's no serial code applied externally, every single device, display, battery, controller, motor, they do not work until they receive the special key that allows them to work with particular, not just abstract aim, but with particular set of core devices. It's only then starts to work. Now we see that this key comes like within like 0.1 second, so it's absolutely transparent for the user. But in terms of safety and security, what does it give? A, it's absolutely impossible to steal or change its parts, because parts will not work absolutely. Even battery, it will not switch on. Basically, the battery will be in off state, same as in controller, same as in display. They will just not work. So you can just replace them to any other scooter, even on the same model, it won't work. This is one. But also, the other feature is that every single part could be controlled via production, and we could monitor its working life. So we could know exactly where this device been installed and how it performed, what problems it had, and what fails it has. By the way, each device, motor, controller, battery, display, has got inside static memory, which records permanently all the fails and all the critical states which every single device experiences. Basically, you can remotely check not just current state of the system, but also you can check what previous mistakes or previous fails or semi-failed or critical conditions system has experienced. So basically, when someone comes with the warranty, we can always check what has happened, and we know exactly. Besides, inside the system, there's a real-time clock, and this real-time clock supplied by the battery itself, it is eternal. As long as the battery lives, and it lives like forever, the clock is always working. So remove it is impossible. It's not possible because this clock works from the capacity of this battery. So it's like forever. And we not just know some fail or some critical state of any part of the scooter, but we know exactly when it happened, from the date of production, of date of the assembly of the scooter. This is like very nice feature. It's mostly used, of course, for the rent, but it also is a nice feature. So, now, the controller. Controller is automotive grade, and it utilizes advanced mathematics, and it uses field-oriented control to control the motor. It also communicates with the battery. And another uniqueness of this system, that this system is built by automotive standard. How? In every transport which is powered by electricity, the battery is the main source of power. Now, because the battery is a chemical source of power, it has certain parameters at which it can work, depending on its current state, residual capacity, state of charge, temperature, blah, 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 blah. And type of the cells, etc. Now, depending on the parameters supplied by the manufacturer of the cells, we can build a mathematical model which shows how to control this battery properly.